Welcome to Chapter 9a, Concept 3, where we will be talking a little bit more about parabolas. Today we're going to talk about finding the zeros, roots, or solutions on a graph. And zeros, roots, and solutions, these are all synonyms, which means they mean the same thing. They're words that we can use interchangeably. Okay, so we're going to be looking at what are zeros, what are roots, and what are solutions when we're talking about a graph. It's kind of the same thing as if your name was Jonathan. You might go by John or Johnny or Jay or something totally not related to Jonathan at all, but they would all be names for you, kind of like nicknames. So these are nicknames for a very important part of the graph. Let's take a look at what that is. An x-intercept is wherever the graph touches the x-axis, and we've dealt with intercepts before, so that shouldn't be too crazy. Another name for x-intercepts, or another way that we can refer to x-intercepts, are these special synonyms where we can call them zeros. Sorry for my spelling error. Zeros, we can call them roots, or we can call them solutions to our graph or to our parabola. A quadratic, remember the quadratic is just a fancy name for parabola. That's the name of the equation, and parabola is the name of the graph. So a quadratic equation can have 1, 2, or no zeros. And that's, remember we've talked about this before, where it could be a parabola like this, where it touches the x-intercept, or it touches the x-axis twice. It could be a graph like this, where it touches the x-axis one time, just right there at that one spot. Or, of course, we could have a parabola that is off in the corner somewhere and never touches the x-axis, and that would be an example of a parabola that has no solutions. All right? We'll be using a sentence frame in this concept to help us talk about these graphs in detail in a way that makes sense and in a way that we can make sure we've covered all the important parts. So the first 3 parts of this sentence frame you've seen before, and we're just going to add on this last little phrase at the bottom where we mention that the parabola has a certain number of roots, and then we'll say they are located at, and we'll give the location of those. So let's take a look at a couple of these sentence frames together. If we look at, all right, let's take a look at these examples here. The question is, how many zeros, identify how many zeros the graph has and what they are. So we're going to say how many zeros and what they are. But in order to do that, we need to get a whole picture of this parabola. So we're going to say the parabola opens up, and it has a minimum vertex at where? Well, I know the vertex is right there. So on the x-axis, it's 4, y, -1. So that means the vertex is 4, -1. That's my vertex point. This means the axis of symmetry is x equals, remember the axis of symmetry goes right through that vertex. So whatever your x value is, that's your axis of symmetry. It's right here. X equals 4. The value of a, the number in front of x squared, is just 1. So that means the graph is, you got it, normal. Normal. This parabola has, okay, so this is our extra sentence, our new one. I want you to highlight the x-axis because that's where we're looking. We're looking to see where does this graph touch the x-axis, and we can see that it touches right here and right here. So this parabola has 2 roots located at, let's see, this is 3, 0, 3 on the x-axis, 0 on the y, and 5, 0. 5 on the x-axis, 0 on the y. So those are the coordinate points of these 2 zeros. Let's take a look at another one. This parabola opens up and has a minimum vertex at where? Right here. That's -1, 1. So -1, 1. The axis of symmetry is going to go right through that vertex, so x equals -1. And a, the value of a, remember a is this number right out front of the x squared. In this case, it's just 1. So the value of a is 1, so the graph is normal. Remember, 1 means normal, fraction means fat, and anything else is skinny. This parabola has, okay, we're talking about roots, so I'm going to highlight the x-axis, and I'm looking, where does this parabola touch the x-axis? Uh-oh, it doesn't touch it at all. So that would be, this parabola has no roots. No real roots, anyway. So it has no real roots, and you don't need to fill out the rest of it because there isn't a location. Okay, so I'm going to leave these two for you to do. Let's take a look at what we're going to do if there isn't a sentence frame, because sometimes there's not. So here they're asking us again, identify how many zeros it has and where they are. And if you need to, approximate if necessary. That was in our instructions. So here we have a graph looking again at the x-axis. Where does it touch the x-axis? It doesn't. So we would say that there are no real roots. Okay? There's no real roots. It doesn't touch the x-axis, so we can't look at it and give you a number because they're not there. Sweet. The second one, if we look at the x-axis, we can see that it crosses the x-axis here and here. So where are those points? What are they? Remember, we want an x and a y, but take a look. This is not quite all the way to -1. And this one is not all the way to 3. It's in the middle somewhere, so it would be a decimal. We can approximate a decimal. We could say that this is maybe 2.7, because it's definitely bigger than 2.5. So we could say it's 2.7. And we could say that this one is maybe -0.7. That would work. Or you could also just write between 2 and 3 and between 0 and -1. So this has 2 real roots. And that's all there is to it. Why don't you go ahead and finish up these last two, as well as your 2 sentence frame problems, and come on to class ready to rock and roll.